Hello, Facebook fans and YouTube fans of DX Engineering. It's Friday afternoon, and boy, after a long week, it is great to be talking about the weekend. And so it's 4 p.m. Eastern time here in the eastern part of the USA, and it's 20 Zulu, June 10th, 2022. It's time for the weekend special, and you never know what you're going to get on the weekend special. Uh, and today we have a very special guest, and he's coming back. So hang in there. It's going to be good, and we'll be looking for any questions you might have for Frank W3LPL that you might put in the comment area. So I will be watching the chat room as always, and it's great to have viewers from all around the world that tune in and watch us here, even in the middle of the night in Australia and Indonesia, India, and India where it's like 1:30 in the morning, and because some of these places are plus 30 minutes, which is a pretty interesting thing in itself. But today we're going to talk about 6 meters, and Frank W3LPL has a lot of experience on 6 meters, and we're going to talk about 6 meters. We're going to talk about the propagation, and it's going to be good. And let's see here. Matt says, what can I put on my copper ground rod and copper wiring outside to prevent it from tarnishing? Well, one of the things, Matt, that I like to use on things that I want to keep from tarnishing is vapor wrap or the butyl tape. And so the vapor wrap that we have at DX Engineering, you can put that right around that connection, and that will keep it from tarnishing. And we have 2 Echo 0 radio Echo Echo. Andy is on with us today. And another Donovan, Whiskey 9 Kilo Kilo. Cliff, nice to see you. And Frank will be, W3LPL will be with us soon. Kilo Kilo 4 Zulu Delta Zulu. Matt, nice to see you. And Andy says 6 meters has been wide open in Europe. And, you just don't know what's going to happen on 6. That's the magic band. And that's part of the magic is and one of the great things is that we have a lot of things now that we didn't have many years ago to see what propagation is doing. And our friend Jeff, KB8ZWT from Tuesdays with Tim and Jeff. Jeff is on today watching. And so Jeff's going to get a little update about 6 meters here. And from Scotland, it's Golf Mike 4, Zulu, Juliet, India. And Chris, nice to have you on. And Dan, WA4 Mike Oscar Mike. And Matt says, as a technician, what are my privileges on FT8? Well, you can operate FT8 on the VHF bands, 50 megahertz and up, and also on 10 meters, you can operate FT8. So you do have privileges to do FT8 as a technician. And we want to welcome Frank, W3LPL. Hello, Frank.
Hi, Tim.
So, Frank, tell us a little bit about what is going on with Sporadic E and 6 meters, the Magic Band.
This is an incredible year. We're really seeing, let's step aside from Sporadic E for the moment. We're really seeing this year the effects of the new solar cycle. Transequatorial propagation, which is an F2 mode that primarily links the northern hemisphere, well, the United States down into South America, really picked up in March. And it was very good last weekend also. And it's been quite good. And that's an F2 mode. And it's better this year than it's been for the last 6 or 7 years because of the new solar cycle. So that's F2. It's a lot of fun. A lot of activity in Argentina and Chile and southern Brazil. But another thing that's really picked up is what I'll refer to as long-distance sporadic E. So that's the sporadic E that goes beyond 1,500 miles or so, and that's really picked up. My neighbor W3UR partially completed a QSO with a station in the northern Cook Islands, and both he and I 5 days ago completed QSOs with stations in Kazakhstan, probably a few hundred miles from the Chinese border. So things have really livened up, Tim.
So, Frank, let's dig into these long haul sporadic E. To go to Kazakhstan or to go to the Northern Cook Islands, how does that all work on 6 meters?
Well, the honest truth is that nobody knows for sure. But I'm going to show you a slide, and
Okay.
this is everyone's best guess. So let me do the sharing thing. Just let me know when you see my screen.
Not quite yet. Okay, it's coming up now. Yes.
Okay, so let me go to full screen.
Yep.
And
we need to.
there
we go.
Okay,
there we go.
That's. Let's go to this. This chart kind of illustrates what's going on. The best of anyone's guess. We don't have the instrumentation to really prove that this is what's going on, but this appears to be what's happening. And that is, of course, I'm located in Maryland, and this long distance sporadic E, which is my preferred way to refer to it, is very low angles. But fortunately, on 6 meters, you don't need massive antennas to work low angles. 25 feet high is high enough. 50 feet high is kind of ideal. And what appears to be happening for this really long distance stuff, and what do I mean by really long distance? I mean Europe and Mideast and Hawaii and Japan. It's kind of routine, close to routine at this time of year. And what appears to be happening is that the sporadic E ionization patches that we use for just simple 1,000-mile, 1,500 miles communications, those patches are very, very widespread in June and July. And what appears to be happening is if we get a signal propagating up into one of those patches near us, let's say 600, 700 miles away, there's a very good chance it can propagate hopping along from one patch to another, and finally find its way back to the ground in pretty amazing places for 6 meters, like Kazakhstan, like the QSO that I had last week, or Japan, which is the 6 has been open to Japan from some parts of the United States quite a bit. So this appears to be the mode.
And, Frank, is there any tip off? I mean, how do you know that this stuff is going on, or do you just have to be on?
You don't really know because you can get surprised. For example, my neighbor's half QSO, incomplete QSO with the Northern Cook Islands yesterday was a total surprise. He was just testing his antennas and looking at propagation across the US, and then suddenly he got an email from E51WL in the Northern Cook Islands saying that I copied you for a minute. It was a total surprise. So the answer is that some of the time it's a total surprise, but at other times, probably the best clue is if you use a website like PSK Reporter, and people can find that just by using Google and searching for PSK Reporter. What you'll typically see if the band isn't open for you is if things are likely to get better, you'll probably see sporadic E propagation in areas within 1,000 miles of you. And then it's a matter of waiting and hoping that the propagation drifts in the ionosphere, which it often does. And if you get lucky, maybe it'll come to you. If you don't get lucky, well, maybe tomorrow will be better.
And one of the chats here in the chat room is from a ham in Scotland, Frank, and he said they've had an opening on 6 meters from Scotland into the Caribbean. And he's asking, is that TEP or sporadic E?
Oh, there's a very easy answer to that one. The equator passes through an appropriately named place called Ecuador. So the Caribbean is far north of the equator, so it can't possibly be TEP, and there isn't any other F2 mode that will support propagation on 6 meters at this part of the solar cycle. So the simple answer is that the only possible mode is long distance sporadic E, using exactly the kind of propagation that's on the screen.
So, Frank, in the Northern Hemisphere, why is it that June and July, maybe even a little of May and a little of August, are the best times for sporadic E on 6 meters, 10 meters, even 15?
Yeah, let me go to another slide. This is a very complicated slide. And by the way, if anyone wants a copy of these slides, just send me an email. I'll show you my email address right here, or you can find it on qrz.com. But my email address is donovanf@erols.com. So if anybody wants a copy of some of these slides, I'll be happy to send them. Let me answer your question. And this is an extremely complex answer to an incredibly simple question. But this sporadic E, and I showed Tim this slide a little earlier, this is the operative mode about sporadic E. Everything you thought you've learned and all of your experience in ham radio having to do with HF propagation, it doesn't apply to sporadic E on 6 meters. Even if you're familiar with sporadic E on 10 and 15 meters, for example, it behaves a whole lot differently on 6 because we're operating close to or even above the MUF. So this is it looks simple, but this is really important to understand that it's just a whole lot different. And this very complicated slide, which I'm not going to try to explain in detail, is what it's really all about. And that is for our normal F2 propagation that's so common on the HF bands. It's always there on 20 meters, for example, 24 hours a day, 365 days a year. On 6 meters at this time of year, June and July, which is what your question was, what's happening is that the source of ionization is not solar driven. For F2, the source of ionization is ultraviolet radiation, a particular form called extreme ultraviolet radiation. But the ionizing source on the sun, the ionizing radiation, is ultraviolet. Well, for sporadic E, it has nothing to do with that, absolutely nothing to do with it. What it is a fancy term called ablation. Think of it as vaporization of tons and tons of metallic meteoroids that come into the atmosphere every day. And unlike ionization of the F2 region, these heavy metallic meteoroids, once they're ionized, they stay ionized for hours and hours, even a day. So it's very long-lived. And in June and July, and this has, again, nothing to do with the sun, it has to do with meteorology, at very high altitudes, roughly 95 to 130 kilometers altitude, there are some winds. They're called zonal winds. It's another fancy term that refers to winds that flow parallel to the equator, so very accurately east and west. And there's a set of easterly winds that are at about 100 kilometers altitude, and there's another set of opposing winds, and this is the key to the answer to your question. In June and July, there are these easterly winds at about 100 kilometers altitude, and there are westerly winds just above. So they're at about 120 kilometers altitude and above. So that creates a wind shear condition between these two sets of opposing winds. And these winds are primarily present during June and July. So that's the primary cause of the June and July incredible peak of propagation in the magic band, or these zonal winds that start really picking up late May, early June, and then they start fading away in August. How's that for a complicated answer to a really simple question?
No, that's a great answer, Frank. But if I've got an antenna at 25 feet, and maybe it's a directional antenna, so it might be even a 2-element Moxon, might be a small 3-element beam, because an antenna 4 or 6 meters is really not that large. I mean, what direction should I point it? For the sporadic E. I mean, how do we go about this?
Yeah, well, that complicated question has a really simple answer, and that is, on 6 meters, all propagation is true short path. So you figure out using your great circle map, you figure out the azimuth between your location and Kazakhstan, and you point the antenna that way, and it will always be correct.
So so there's no bent path or scatter. I mean, this is the real deal. And contrast kind of FT8 and how it has changed the game on 6 meters.
Yeah, that's a really good question. And that has nothing to do with any of these slides that I've prepared for the antenna forum in Dayton. FT8 has dramatically increased the amount of activity on all of the bands, 6 meters included. It's just incredible how much activity there is all the time. If you go on PSK Reporter and you select 6 meter only, there's about 2,500 stations that are reporting the signals that they copy on FT8. And if there's a band opening, I've worked well over 1,000 different stations in Europe on FT8. And there's always new stations. So this year there's been 3 or 4 really, really good days of propagation into Europe. And it's just like I've never worked anybody. There's all these hams that have just showed up on 6 meter FT8 for the first time. And there are these pile-ups of stations that are calling you, and they're call signs you've never heard of before. And they're just having a whole lot of fun working across the Atlantic into North America using FT8. So it's brought a whole series of hams, a lot of them new hams, into 6 meter DXing who never would have done it before FT8 showed up on the scene.
Yeah, and that's just incredible. I mean, anything that gets people on the air and making contacts, and of course, who doesn't like DX, and to do it on 6 meters? Now, there's a question in the chat room, Frank. It says, what about E-skip in December? Is it different from June and July?
Yeah, it is. And again, there's no real simple answer to that question, but I'll try to answer it in a simple way. In the southern hemisphere, that's their peak sporadic E season. So that's their summer.
Right.
So, and in the northern hemisphere, there's a minor peak in from about mid-December to about mid-January. And it's, if you think sporadic E is frustrating in June and July, and it is, it's extremely frustrating in December and January here in the northern hemisphere, because it's only open for longer distance propagation for 1 or 2 days, maybe 3 days over that 1 month period. But again, the operative word is magic. On Christmas Day, about 5 years ago, there was an opening from many areas of the East Coast to New Zealand in December. And it was this long distance sporadic E again, probably coupled with TEP. But you just never know. The very best time of year for sporadic E is June, July. And now with the solar cycle peaking up quite a bit, we can use this F2 mode called TEP, transequatorial, and that peaks from late March until early June, and then it kind of goes away. And then it picks up again in from late September through early November. So there's a lot of stuff you can do on 6, but you have to be patient for all these modes.
So Mark is on M0DXR from London, and he says many USA in the log, 7 JAs. When is the official peak for this season time-wise?
Yeah, hi Mark. That's a very good question. So, and again, I have another slide that shows the answer to that question. So, in terms of month, these are actual measurements that were made in Athens some time ago. You can't measure the influx of these tiny dust-like meteorites. You just can't do it. They're too small. But their maximum coincides with the maximum daily count of meteors, which you can measure. And to prove the correlation, on the right-hand side of this chart is the vertical incidence critical frequency for sporadic E. So you can see that in brown, you can see what that peaks from mid-May, starts to peak in mid-May, reaches its maximum around the 1st of July, late June, early July, and then starts to decline in the middle of July. So this chart proves that these dust-like micrometeorites that produce sporadic E, that their occurrence is highly correlated to meteors, which is shown in blue, which we can measure. And you can see very clearly in this chart in blue that the daily average meteor count, meteors are unrelated to sporadic E, also peaks from mid-May through mid-August. So to get to very directly to Mark's question, the peak time is plus or minus about 2 weeks from the summer solstice, more or less 2 weeks. So we're just entering the peak time right now, but it was really good around June 1st. And you'll notice a significant decline starting in the middle of July. But we can have some really good days of long distance sporadic E right through the end of July, and maybe even one day in early August.
Well, it certainly is an exciting time of the year, and when you think about the possibilities and some DX with, the antennas don't have to be big. You don't have to have a whole lot of power, and certainly with FT8, it just opens up all sorts of opportunities. Frank, we could go on for hours. Here, talk about this antenna here. Talk about this.
Yeah, so this is Tim is right on the money. You don't need really fancy antennas to enjoy this propagation on 6 meters. This is just one example of a very lightweight 3-element Yagi. It's a 7-foot boom. It weighs only 6 pounds. And you can mount this on the end of a 25-foot mast. And you could work some of this long distance DX on 6 meters with a real simple antenna system like this. It would work better if you can get it up at 40 or 50 feet, but it works well enough even at just 25 feet. So you can imagine this entire kit of a 3-element Yagi and a 25-foot mast probably only weighs about 25 pounds.
It's pretty incredible. And you can build these things. I mean, you Google it on the internet and you can build antennas like this and really have a lot of fun.
I bet you even recognize some of this material that you can buy.
Yeah, that's right. At DX Engineering, we have all the aluminum you need. But you can go ahead and stop sharing, Frank. And I just want to thank you so much for coming on today to talk about 6 meters and talk about some of the fun that you're having, and also share some of your expertise with our viewers that are all around the world.
Okay, Tim, you're very welcome. It was my pleasure to do that. And if anyone's interested in these slides, just drop me an email. You can always find my email address on qrz.com. And if you look on Google and search for my call sign, W3LPL, and then after you do the search, click on the video tab, you'll find some of these presentations in more detail. So thanks, Tim.
Okay. Thanks, Frank. And we'll see you on 6 meters, the Magic Band.
The Magic Band. That's right. It's all about fun.
It is all about fun. And 73, have a great weekend. It's the VHF contest this weekend. So everybody get on the VHF bands and make some noise. And 73 from DX Engineering.
73, Tim.